Very good evening friends, and in this video we are going to discuss about the limit of a function. This is the beginning of the calculus series, and those who haven't watched the functions and don't understand what are the functions, domain types of the functions like the injection, surjection, bisections, otherwise they are called as one function, onto function, into functions. So you can watch my previous videos and then you have the better understanding of the something called as function and its types. Now in this video we are going to discuss about the limit, that is called the limit of a function. What is the limit of a function? This we are going to study now. So our topic is limit of a function. Now limit of a function is what will happen. Suppose if I have a simple function fx is x square plus 2. So in this condition, if you say if I put x equal to 2, so we write f2 is 2 square plus 2, that is 6, and f minus 2 is also minus 2 square plus 2 is 6. So we can say the value of the function at 2 is 6 and the value of the function at x is minus 2 is also 6. Now the limit is limit x tends to fx, means when x is approaching to, what will be the value of the function. Suppose I have a function fx is x square plus 2. If I want to draw it graphically, so this will be a quadratic function. So this is of the form like this: y equal to x square and plus 2, it means the vertex is at 0, 2. So if I say f1, so the 1 square plus 2 is 3, so this is 1. So this value will be 3, and since the graph is symmetric about the y-axis, therefore f minus 1 is also 3. Now at x is 2, the value of the function will be 6. So you can take it like that. So this value is 6. Same way here. So these are the values. So at fx2, x is 2, the value of the function is 6. This is that point. Now when we talk about the limit, what does it mean? That limit x tends to 2 means you are approaching 2. And there are two ways by which you can approach 2, because this is a real axis. This you can approach either from this side, like the minus infinity, then this is minus 2, minus 3, minus 2, minus 1, 0, 1, 2. So x is approaching, means x is in the increasing order. So x is coming from minus infinity and then it comes here at minus 2, minus 1, 0, 1 and 2. And then the function you can say, because when suppose x is at very higher value, like beyond this, so let me make it like that. Okay, so when x is here, suppose very, then the corresponding value of the function you can presume that it is coming somewhere here. So when you are coming from this side, the value of the function is coming from this side. So suppose if I make it minus 7 here and then dot dot dot. So the minus 7 square, 49 plus 1, this is 51. So when x is minus 7, this is minus 51. When I make x as minus 2, so it is coming 6. So from minus 52, it is coming towards 6. So when x is approaching from the left hand limit, this is called as the left hand limit. And the notation goes like this: left hand limit, that is limit lim x tends to 2 minus x tends to 2 minus. means x is coming from the 2 and minus means it will always be lesser than 2 because it doesn't have to approach, like it doesn't have to reach there, it is just approaching, try to, because the Cantor-Dedekind real axial system says that between two real numbers there are infinite numbers. So between 1 and 2 there are infinite real numbers. So the x is approaching from the this side to 2. So here also there are infinite numbers. So you can say there are infinite numbers between this. So it is always approaching. It never reaches, because when it reaches, it will be something like that. We can say yes for sure that x is 2 means it has reached to 2 and then the value of the function has become 6. But it is not approaching. It is not reaching there exactly. It's just trying to get as close as possible, and then the notation goes x tends to. So it means suppose when it is just very close to 2, so our value is here, further close here. So you can say that when I am closing to 2, the function is closing towards 6. So because this is approaching towards, because when you are here, then slowly going up, 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 and when it becomes, when you become very close to 2, then you can say the function is approaching 6. That is how it should be presumed or understood. So now limit, this is called the left hand limit, and then right hand limit. Right hand limit means we will be approaching to from this side. So this is left hand limit and this is right hand limit, and this we write as limit x tends to 2 plus fx. And you see that also from this side, suppose it is here, so we are here, so, and here also it is approaching from 6. And when we say that the left hand limit is right hand limit, then we say that since LHL is RHL, then we conclude that limit exists and the value of limit x tends to 2 fx is 6. This is how this limit is. When x is approaching 2 from either side, the function is approaching towards 6. This is the function and this is the idea of the limit. Now let me clear the screen and then we'll try to solve certain questions to have the grasp of the concept. Okay, now suppose here we are given a question, find the limit. Find the limit of number 1. This is limit x tends to 2 x cube plus x square plus 7x plus 2. Then you don't have to do anything, just you can put the value, and since the idea there are 4 terms, 1 term, 2 term, 3 term, 4 term, you can assume that you are writing limit x tends to 2 x cube plus limit x tends to 2 x square plus limit x tends to 2 7x plus limit x tends to 2. So now here you just put the value directly. So this will become limit x tends to 2, so it is 2 cube. So this will be approaching 2 cube, 2 square, 7 into 2 plus 2, because this is independent. There is no x involved, so wherever the x is going, there will be no change in the value, it will always remain 2. So now this is 8, 4, 14 and 2. So 14, 6, 20 and 8, this is 28. But if I have a function like this, limit x tends to 2 x cube plus x square plus 7x plus 2 upon x minus 2, then what do you see? That you have to assume that the limit into a fraction is the limit in the numerator upon limit in the denominator. So limit x tends to 2, that will be x cube plus x square plus 7x plus 2 over limit x tends to 2 x minus 2. Now this one as usual value is 28, and here you get 2 minus 2, that is 28 over 0, which is undefined. Then you can say limit x tends to 2 fx does not exist, means here you cannot find any value for this, because denominator when x is approaching 2, then x minus 2 is approaching 0, and when the denominator of any rational algebraical fraction becomes 0, it means that function will be undefined. So you can put the value of the limit directly into this, and if it is defined, that is your answer, and if it is not defined, then you can say limit does not exist. Now there are another type of case, and that we'll discuss just after clearing this. Now let's take another example. Limit x tends to 2, and then I write x square minus 3x minus 10 upon x square minus 4. So again we'll use the idea of limit, that the limit in the numerator, that is x cube minus 3x minus 10 upon limit in the denominator, that is x cube minus 4. Then if I write the limit for each term, the limit x tends to 2x cube minus 3 times limit x tends to x minus 10 times limit x tends to 1. That will be quite wastage of time, so we can do it directly. So this is 8 minus 6 minus 10 over 4 minus 4. So there you see that limit x square, 8 minus 6 and plus 2. So again this is also going a non-zero over 0, that is undefined. But assume that if this function is minus okay, so this is okay. Wait, I have made a mistake. 2, this is not 8, this is x square. So this is 4. Yeah, suppose if I make this one as plus 10, so 4 minus 6, or better, let me make another example. Just I need to change. So here if I put the value of x is 2, this is 4 minus 6. So suppose I make it plus also. Okay, so and this one 10. Okay, so now if I put the value of this one directly, so what will get? 4 plus 6 minus 10, and this is 4 minus 4. So we are getting 0 by 0 form. But there is a formula that if, that is called the factor theorem, that if fx is x square plus 3x minus 2, and if f2 is 0, like putting the value of x is 2, if I am getting 0, it means x minus 2 is a factor of fx. So both numerator and denominators, you can say they are factors of x minus 2. They have got the factors because just by putting x as 2, I am getting the value of fx 0. So better I just try to get rid of, and then I just try to factorize. So this is x minus 5, plus 5x minus 2. Just by middle term splitting, you can find the factorization of this one. And this is a square minus b square. So this is x minus 2, x plus 2, and limit x tends to 2. So this one is, you are getting 0 by 0 form because of these two terms, x tends to 2 and this 2 minus 2, 2 minus 2. Now here they are common, so they get cancelled. So now if you put the value of limit, you get 2 plus 5 upon 2 plus 2, that is 7 over 4. This is the basic idea of the limit. Now there are many formulas involved in the limit of a function, and we are not going to prove each and every formula, but we will be writing the important formulas. For that I need to get rid of this mess. Okay, so now I'm writing some of the common formulas used, but I'm not going to prove them because that is the beyond, because nobody is asking these days prove those formula, but you can understand this is very easy. So limit x tends to 0, sin x upon x as 1. Limit x tends to 0, cos x is 1. Limit x tends to 0, tan x upon x is 1. Then we have limit x tends to 0, x to the power n minus a to the power n upon x minus a is n a to the power n minus 1. Limit x tends to 0, e to the power x minus 1 upon x is 1. Limit x tends to 0, log 1 plus x upon x is 1 for the base e. Then we have limit x tends to 0, 1 plus x whole to the power 1 by x is, this is infinity, is e. And one more, this is limit x tends to 0, 1, a to the power x minus 1 upon x is log a to the base e. So these are the basic formulas which we'll be using in our problem. So you can stop the screen, you can copy these as the formulas, and then later we'll try to understand how you can correction, friends. And here it should not be infinity, it should be limit x tends to 0. 1 plus x whole to the power 1 by x is e. So this is all, not all, but you know, these are just the basic functions, and you have to learn how to apply and solve these questions of limit. So we will solve some questions and then we'll explain you how you can use these formulas to solve the questions. So subscribe our channel and then keep sharing the videos to your other friends and just get motivated. And this is how the mathematics works.